In this video, we are going to learn about scalars and vectors. To understand scalars and vectors, let me take a simple example. Suppose a body is moving in a circular path at a constant speed of 5 meters per second. Is the speed of the body constant or it is changing? Speed is constant, right? I told you so, speed is constant. Is the velocity constant or it is changing? Velocity is a vector. For that, the direction is important. So velocity at every point will be along the tangent. Therefore, the velocity is changing. The speed of this particle is constant, but the velocity is changing because velocity is a vector. What are scalars? Scalars have three properties. They have got magnitude. They don't have any direction. And they obey laws of ordinary algebra. The algebra that you have learned in school. Scalars obey laws of ordinary algebra. The simplest scalar is distance. Distance travelled. Speed is a scalar. Speed starts with S. That should remind you of scalars. Speed is a scalar. Temperature is a scalar. Pressure, mass, energy, time, all are scalars. They have got magnitude, they have no direction, and they obey laws of ordinary algebra. What are vectors? Vectors have magnitude. They have direction, and they obey the laws of vector algebra, which we are going to learn today and in the next few videos. The simplest vector is displacement. Rate of change of displacement is velocity. Velocity starts with v, vector starts with v, so velocity is a vector. Remember that way. Rate of change of velocity is acceleration. Acceleration is a vector. Mass into acceleration is force. Force is a vector. Momentum is mass into velocity. Momentum is a vector. Torque is the turning effect of a force. Torque is a vector. So this way try to learn examples systematically. Start from displacement, velocity, acceleration, force, momentum, torque. All these are vector quantities. Now, how do we handle direction when motion is in one dimension? When a body is moving in a straight line, it can move in two directions. Suppose the body is moving along this line, it can either move that way or this way. If a body is moving along this line, it can either go up or down. When there are only two options, we use plus and minus sign. Like for charges, there are two kinds of charges. So use plus and minus sign. Same way, this particle can either go up or down. So we can either call up as positive, then down will become negative. If we don't like that, we can call down as positive, up will become negative. So when motion is in one dimension, plus and minus sign are sufficient to give the direction. One direction we'll call plus. The opposite direction automatically becomes minus. If you don't like this sign convention, we can call this plus, then opposite will become minus. So plus and minus sign are sufficient to specify the direction in this case. But every time life will not be so simple. A body can move in 2D or 3D. Then it can move in many directions. So we don't have just two options, we got many options. So then we have to use vectors. Now how do we denote a vector quantity? What is the notation of a vector quantity? For a vector quantity, we put an arrow on top. This is a vector. A vector can start from A and end at B. So for that we write AB and put an arrow on top. So the whole world knows that A is a vector, AB is a vector. For a scalar, we don't put the arrow on top. Now at times we are just interested in the magnitude of the vector. A particle has moved at 3 meters per second. We are not bothered it has moved east, west, north, south. Then we denote the magnitude of a vector by drawing two parallel lines like this. This denotes magnitude of a vector. Now this is cumbersome to write, so we simplify this and just write A. When we write A and we know A is a vector, then that denotes magnitude of the vector. Same way for magnitude of AB vector, we'll write AB and put an arrow on top and then put this mod signs. Or we can just write AB. So this is how we are going to denote the magnitude of a vector. Now how to represent a vector geometrically or graphically? A vector is represented geometrically or graphically with the help of a directed line segment. A line is of infinite length. So this is a segment of a line. And if you put an arrow here, that becomes a directed line segment. And this is the vector. The length of this line is proportional to magnitude of the vector. If you draw a small line, then the magnitude is less. If you draw a big line, the magnitude is more. This vector may represent 2 meters per second. Double this length will represent 4 meters per second. And double of this will represent 8 meters per second. And the direction of this line segment gives us the direction of the vector. This vector may represent 2 meters northeast. This vector is 2 meters east. This vector is 2 meters south. All these vectors are different. Based on your convenience, you cannot change the direction of a vector. For a vector, magnitude and direction both are important. So if two vectors are equal, their length has to be same, their magnitude has to be same, their direction has to be same. Both magnitude and direction are important for a vector. Therefore, a vector can be completely represented by a directed line segment. The length of the line segment is proportional to the magnitude of the vector. And the direction of the line segment gives us the direction of the vector. Now, wherever this arrow is there, that is called head of the vector. And where the arrow is not there, that is called tail of the vector. A vector also has got a head and tail. Where the arrow is there, that is head, no arrow, tail. Now vectors are of two types. First type of vectors are fixed vectors. If you want to scare people, you call them localized vectors. But the easier term is fixed vectors. For these fixed vectors, the initial position is fixed. For example, if this is some x-axis, this is some y-axis, and there is a dot here. And somebody asks us, what is the dot? He can see the x-axis, he can see the y-axis, but he is not able to see the dot. So how will I tell him the position of the dot? So I'll tell him, go at 45 degrees, go for 6 centimeters, you'll find the dot. So this kind of vector is called position vector. And this position vector is a fixed vector. We have to start from here and go at 45 degrees. Then only you'll find this point A or that dot. If you start from here, you follow all the other instructions correctly, you will not find the dot. So this is a fixed vector. Position vector is an example of a fixed vector. The other type of vectors are free vectors. Suppose we are representing 2 meters northeast. We draw a line here, or we draw the line here, or we draw the line here. It all represent 2 meter northeast. These kind of vectors are called free vectors. And you want to scare people? We call them non-localized vector. These free vectors have got a useful property. They can be shifted parallelly as long as we keep length and direction same. And that is very, very useful. Example of free vectors are displacement, velocity. All these are free vectors. Now let us learn about displacement vector. What is displacement? Displacement is change in position. I am in Mumbai now, and suppose I am in Pune tomorrow. Then my displacement is Mumbai to Pune. Displacement is change in position. Displacement vector is final position vector minus initial position vector. So I am in Mumbai now, and tomorrow I go to Pune. I can go by plane. I can go by train, right? I can go by bus. I can go by cycle. I can go by walking. Nobody is preventing me from walking from Mumbai to Pune. Whatever I do, the end result is same. My displacement is from Mumbai to Pune. All paths represent the same displacement. Displacement does not depend on path. Somebody wants to meet me in Pune tomorrow. He or she is not bothered whether I go by train, plane, walking, bus, cycle. So displacement is basically path independent. Displacement does not depend on path. Now based on this, we can understand how we can add fixed vectors. So let us learn adding fixed vectors geometrically. And the first method is triangle method. So suppose from Mumbai, I go to Pune. Let us go to Pune again, right? No harm. And from Pune, I go to Delhi. The first displacement vector is Mumbai to Pune. Let me call it A vector. The next displacement vector is Pune to Delhi. So that is B vector. And what is the overall result? I move from Mumbai to Delhi. This is the resultant. If somebody wants to meet me in Delhi and I don't get a direct flight to Delhi, then I can go to Pune, and from Pune I take flight to Delhi. The result is I move from Mumbai to Delhi. Therefore, C vector is equal to A vector plus B vector. Now pay attention. Suppose Mumbai-Pune distance is A. Pune-Delhi distance is B. And Mumbai-Delhi distance is C. These represent the magnitude of these vectors. C is not equal to A plus B. Understand the difference. C vector is A vector plus B vector. But C is not equal to A plus B. All of you know, any two sides of a triangle are greater than third side. So obviously A plus B is more than C. But C vector is A vector plus B vector. This is the difference between scalar algebra and vector algebra. Now, if we add A vector and B vector, we are getting C vector. So what is the maximum possible magnitude of C? Suppose all these three places are in the same straight line. So Mumbai is here, Pune is here, and Delhi is here. Don't worry about geography. We are learning physics, not geography. So all are in one line. First we go from Mumbai to Pune, that is our A vector. Then we go from Pune to Delhi, that is B vector. And the resultant is Mumbai to Delhi, C vector. And see the beauty here. Here C vector is A vector plus B vector. And C is also equal to A plus B. So if C vector is A vector plus B vector, and A vector and B vector in the same direction, then in that special case C is equal to A plus B. And this is C maximum. Suppose you go 200 kilometers from here, then you go to 800 kilometers in any direction you like. The maximum distance from the starting location will be 1000 kilometers. So if C vector is A vector plus B vector, then C maximum is A plus B. What is C minimum? Suppose A vector and B vector in opposite direction. Mumbai is here and Pune is really far off, very far, and Delhi is somewhere in between. So first we go from Mumbai to Pune. If C vector is equal to A vector plus B vector, what is the minimum possible value of C? That will happen when the vectors are in opposite direction. Suppose they have got M here, P very far off, and D is in between. First we go from M to P. This is A vector and magnitude of this is A. And from P we come back to D and this is B vector. Magnitude of this is B. What is the resultant displacement? We have actually moved from M to D only, and that is C vector. So C vector is A vector plus B vector. But look here, what is C equal to? This C. C is equal to A minus B. And this is the minimum possible value of magnitude of C vector. So from this we learn that if C vector is A vector plus B vector, then C will always be less than equal to A plus B, and C will be more than equal to magnitude of A minus B. Now this is very important to remember. This question people will ask you in exams, right? So you should know this clearly. If C vector is A vector plus B vector, then C will always be less than equal to A plus B, and it will be more than equal to mod of A minus B. Why mod? Depending on whichever is greater, we have to subtract them. If A is greater than B, we do A minus B. If B is greater than A, we do B minus A. Suppose the magnitude of A vector is 800 units and magnitude of B vector is 200 units. What is the maximum possible magnitude of C? 1000. 800 plus 200. So with these two vectors, we cannot get a resultant more than 1000 units. What is the minimum value? 800 minus 200, that is 600. So we cannot get anything less than 600 units. As you solve questions, please remember this. Now we can have a special case where B vector is perpendicular to A vector. Suppose this is M. From M we go to P, and from P we go to D. The angle between them is 90 degrees. This is A vector. This is B vector. The resultant is like this, which is C vector. Here in this special case, C vector will be A vector plus B vector, and C will be root over A square plus B square. Thanks to Pythagoras, right? All of you know Pythagoras theorem. So since this is a right angle triangle, if this is A, this is B, this is C, C will be root over A square plus B square. This is how we add fixed vectors by triangle method. When we have more vectors, we have to use polygon method. Polygon method is nothing but extension of triangle method. Suppose I start from Mumbai, and from Mumbai I go to Pune, right? From Pune I go to, say, Nagpur. From Nagpur I go to Kanpur. From Kanpur I go to Delhi. And from Delhi I go to New York. Right? So what is my displacement? What is the resultant of all these displacements? I basically move from Mumbai to New York. This is the sum of all these vectors. A vector, B vector, C vector, D vector, E vector. So this is how we add vectors by polygon method. All these are fixed vectors. Now we will see how to add free vectors by triangle method. Now we will learn how to add free vectors by triangle method. Free vectors can be shifted parallelly as long as we keep length and direction same. Now we have got these two vectors, A vector and B vector. We want to add them. So what is the first step? First step is shift the tail of the second vector to the head of the first vector. Always remember tail to head. So draw A vector as it is and shift the tail of this B to the head of A. Now we join the tail of A to the head of B. So we join the tail of A to the head of B and we get this vector. This C vector is A vector plus B vector. Always remember, we are shifting tail to head. We have shifted tail of B to head of A, and then we have joined tail of A to head of B, and that gave us the vector sum. Suppose we got more vectors, then we have got polygon methods. Suppose we got this as A vector, this is B vector, and this is C vector. So how to add them? Keep on shifting tail of the next vector to the head of the previous vector. So A vector we draw like this, and tail of B has come here, and tail of C will come here, and then we join tail to head, and that gives us the sum, right? So this is how we add more than two vectors. For two vectors, triangle method. More than two vectors, polygon method. Polygon method is nothing but an extension of triangle method. Now, this vector addition follows certain laws. First law is A vector plus B vector is same as B vector plus A vector. We can add vectors in any order. This is called commutative law. Second law, A vector plus B vector plus C vector is same as A vector plus B vector plus C vector. This is known as associative law. Now, to add vectors, we have got parallelogram method. If this is one vector, A vector, and this is another vector, B vector, to add them by parallelogram method, we bring the tails together. So parallelogram method will draw A vector like this and B vector like this with the tails together, and this common tail, let us call it O. Where the A vector ends, let us call it A. Where the B vector ends, let us call it B. Follow this nomenclature so that life is simple. Now we will complete this parallelogram. Parallelogram has got a very useful property. opposite sides are equal. So this is A, this will also be A. This is B, this will be B. Opposite sides of a parallelogram are parallel and equal. Let us assume that the angle between these two vectors is theta. So this vector is given to us, this vector is given to us, angle between them is theta. Our job is to find this resultant. This diagonal represents the resultant. We want to find the length of this line C. And also we want to find the angle the resultant makes with the first vector. This is all that is required. Now we want to get an algebraic relationship to find the sum of two vectors. Vector A is known, vector B is known, theta is known. C is not known, alpha is not known. So now we want to find C. The next method of adding free vectors is parallelogram method. Suppose you have got this as A vector and this as B vector, and we want to add them by parallelogram method. The first step is bring the tails together. So now we'll draw the two vectors with their tails together. This is that same A vector, this is B vector. The angle between A vector and B vector is given to us, say it is theta. Now we want to find the resultant. So what we'll do? We'll complete this parallelogram. Parallelogram, opposite sides are parallel, right? That all of us know. And opposite sides are also equal. If this is A, this will also be A. This is B, this will be B. Now once we complete the parallelogram, this diagonal from the common tail to the diagonally opposite corner represents the vector sum. Geometrically same like triangle method. In triangle method we have drawn B vector here. Now we are drawing B vector here. So geometrically same. But this method is useful because it gives us an algebraic relationship. And that is what we are going to work on now. Now let us call the common tail as O. Where the A vector ends, let us call that as A. Where the B vector ends is B. All this just to make life simple. You follow this nomenclature, derivation will look very easy. Now C vector ends C. This C is the vector sum. Length of this line is C. Now we want to find basically algebraic relationship for C. And we also find this angle that the resultant makes with the first vector. That is our job. So how will you do that? Let us extend this line so that we can drop a perpendicular from C. So this is 90 degrees. Simple. Let us call this point D. Now to make things even more simple, let us call this AD as X and CD as Y. This angle is theta. So what will be this angle? Right, that will be theta because that is corresponding angles. These are parallel lines, right? Now we know this angle. We know this AC, that is B. Our job is to find X and Y. These variables we have introduced. So we should know what is X, what is Y. Look at this triangle ACD. What will be cos theta? Cos theta is adjacent side by hypotenuse. So cos theta will be equal to adjacent side is X and hypotenuse is B. So X becomes B cos theta. Right? Now look at that same triangle ACD. that small right angle triangle. What is sine theta? Sine theta is defined as opposite side by hypotenuse, y by b. Therefore, y becomes b sine theta. Right? So now we know x and y. Our job is to find c. So how to find c? Yes, Pythagoras theorem. C square will be a plus x whole square plus y squared. Therefore, c will be equal to root over a plus x whole square plus y square. Right? And you know x and y. You can put it in this equation. So what do you get? Root over a plus b cos theta whole square plus b sin theta whole square. Right? And now we can expand that. All of us are expert in algebra. So this becomes root over a square plus 2ab cos theta plus b square sin square theta plus b square cos square theta. Right? And I can take b square common. And all of you know sin square theta plus cos square theta is 1. Therefore, this c becomes root over a square plus b square plus 2ab cos theta. This is the formula for resultant. And this is what we need to memorize. Now we need to find this angle. Now look at that right angle triangle OCD. What is tan alpha equal to? Opposite side by adjacent side. So you can easily see tan alpha will be y by a plus x. What is y? B sin theta. And what is x? B cos theta. So now we have got a relationship for tan alpha. So we found the angle and the magnitude of the resultant. Let's first try to learn negative of a vector. Negative of a vector has got the same magnitude but opposite direction. If this is p vector, minus of p will be like this. Same length but opposite direction. If this is q vector, then minus of q will be like this. Opposite direction. Now based on this, we can learn vector subtraction. Suppose this is p vector. Okay, this p is different from that p. And this is q vector. And we have to find p vector minus q vector. So first we'll draw minus q. Minus q will be exactly like q, but the arrow will be on the opposite side. After this, don't look at q. Don't look here. Just look at minus q. And add p vector and minus q vector. So what do you get? P vector here, minus q vector here, and this represents p vector minus q vector. That's all. P vector minus q vector is nothing but p vector plus minus q vector. This is vector subtraction. Now, in the parallelogram method, we learned that if this is a vector, this is b vector, this represents a vector plus b vector. The other diagonal represents a vector minus b vector. See here, this is a vector, so this will also be a vector. This is b vector, so minus of b will be like this. And therefore, this diagonal represents a vector minus b vector. So in a parallelogram, one diagonal represents the vector sum, other diagonal represents the vector difference. So based on this, we can draw certain conclusions. All of us know that if A vector and B vector have the same magnitude, then we'll get a rhombus. So if magnitude of A vector is equal to magnitude of B vector, we get a rhombus. And what are the properties of a rhombus? Right? The diagonals cut at right angles. Therefore, if mod of A vector equal to mod of B vector, A vector plus B vector and A vector minus B vector will be at right angles. That is the property of a rhombus. Also, we know that for a rhombus, these two angles. Also, we know that diagonals of a rhombus cut at right angles. Therefore, if magnitude of A vector equal to magnitude of B vector, A vector plus B vector and A vector minus B vector will be mutually perpendicular. These diagonals of a rhombus also bisects these angles. Therefore, if theta is the angle between the two vectors, then the resultant will make an angle of theta by 2 with either of the vectors. So this is one important conclusion. If magnitude of both the vectors are same, diagonals cut at right angles, so vector sum and vector difference will be mutually perpendicular, and this resultant will be making an angle of theta by 2 with each of the vectors. Now, when will the vector sum be equal to vector difference? That we'll get when we have a rectangle. We know that diagonals of a rectangle are equal in length. So if this is A vector and this is B vector, then this diagonal is A vector plus B vector, and this diagonal is A vector minus B vector, and these two are equal in length. So when A vector is perpendicular to B vector, then magnitude of A vector plus B vector will be equal to magnitude of A vector minus B vector. Diagonals of a rectangle are equal. Right? Very simple.